Okay, here's a good question. Limiting reactant question. So, you've got ammonia plus oxygen gives nitrogen oxide and water. When I look at the balancing for, I think we need to balance this a bit different. Some of those might be right, but let's see. So 4 ammonias, so I need 4 of those, the nitrogens, to balance the nitrogens. Then I have 12 hydrogens, so I need 12 hydrogens. So 6 times 2 gives 12. And then 4 plus 6 is 10 oxygens on this side. I need a 5 there. Okay. Then I need to, they give me grams of each of the reactants. So I need to determine moles of each. So divided by that, so this would be moles of ammonia, and this would be moles of oxygen. Good. So now with limiting reactant questions, what we do is I always just take the first one, and then I determine, forgetting that this one's here, let me just block that off. Forgetting that that's there, I determine how much oxygen I need. So it would be 0.9072, etc. moles of ammonia. If I have that much, then according to my mole ratio, so 5 moles of oxygen to 4 moles of NH3, so I need to times that by 5 and divide by 4. Let me get my calculator. Okay, when I do that, I come up with 0.2384 moles of oxygen. So to use up all this ammonia, I need this much oxygen. Now let's just look to see how much oxygen I have. I only have 0.109 oxygen, meaning that the oxygen, this oxygen is my limiting reactant. Okay, so now I can sort of forget about the ammonia. Okay, now let's do some more math here. So I've established that oxygen is my limiting reactant. So when I do my stoichiometry, I'm starting here with mass of oxygen. This is my oxygen side. This will be my, we're looking for NO, so this will be my NO side. So I'm going to have to do step 1, step 2, step 3. So step 1 I did already. I found how many moles of oxygen I have. So moles of oxygen are 0.109375 moles. Okay, so that's step 1 done already. Step 2, I have to take that number and times it by, I'm going to NO. So it'd be 4 NOs for every 5 oxygens. Okay, let me do that on the calculator. Okay, that gives me 0.0875 moles of NO. And then finally, step 3 is to take and find mass of NO. So nitrogen is 14.01, oxygen is 16, so altogether that's 30.01. So I need to go from moles of NO to mass of NO. So that is mass is equal to moles times molar mass. So 0.0875 moles of NO times molar mass of nitrogen oxide is this, grams per mole. So let me multiply those. .625. Yep, grams. Now it's probably 3 sig figs, so I'd round that to 3. So 6.2 2.63 grams of NO. Now let's see if they ask us any other questions. Whoops. Okay, B. Okay, I found the limiting reactant. How many grams of NO are formed? Found that. And then they say how much of the excess reactant remains. Okay, so this is my excess reactant here, and I want to know how much it remains. So what I need to go back and do is find out if I use this much oxygen, how much of the ammonia will I use? Okay, so let's do that. So for excess, I have 0.109375 moles of oxygen. And if it were to react 4 moles of ammonia, react with 5 moles of oxygen. Okay, so let me just show you where I did that. So I have this. That's this one right there. So I have to multiply it by 4, what I'm looking for, divided by 5. Okay, let me do that. Okay, so when I do that for the excess, I get 0.0875. Oh, that's the same as the one I had up there. But this one is for ammonia. Okay, so that's how much ammonia gets used. So when I look up there, I actually have this much ammonia. So if I have 0.19072 moles of ammonia, then I need to subtract 0.0875 moles to figure out how much I have left. So if you do that on the calculator, that would be 0.103, I think. And I think that's what was the answer. And you can convert that to grams if you want. Okay, hopefully that helps.